Okay, hello everyone, in a new video. So we have reached part 5 of chapter 4, which is the chapter of resistors, and the second unit, which is unit of electricity. Then now we are in section number 23, exercise number 14. In order to determine the nature of an electric component D, we connect the electric circuit of the adjacent figure. Then they mention this figure, now we can use it. This circuit includes in series a generator G maintaining across its terminals a constant voltage of adjustable value. So notice that here the arrow labeled on the battery or the generator G indicates that the value of UG is adjustable, or Upian. A digital ammeter A of negligible resistance, the electric component D. Now notice this, till this moment they didn't mention anything about this document, so we are not allowed to use it. Now in number 1, redraw the diagram of the electric circuit and indicate on it the terminals A and COM of the ammeter in order to display a positive value. So notice that here the ammeter is reading the electric current traversing the circuit because this is a closed circuit. So the ammeter will either indicate positive or negative reading, and this depends on the COM terminal. Then moving from the positive pole, this is positive, this is negative. So they are telling me that the ammeter must display a positive value, which means the COM terminal must be connected to the negative pole. So this is the COM terminal, and this is the A terminal, the other terminal, which is indicated by A. Now we need to redraw the diagram. So this is the generator G of adjustable value, this is the point P, this is the ammeter A, this is the electric component D, this is the point C, okay. So this is the COM terminal, and this is the A terminal. Now in number 2 they are telling me, in order to measure the voltage UBC across D, we use a digital voltmeter. In 2.1, represent this voltmeter on the redrawn figure indicating its V and COM terminals. So notice that here the voltmeter is measuring the voltage UBC across D, and we know that the voltmeter must be connected in parallel, so this is the voltmeter. Now it's left to represent the V and the COM terminal, so, or in other words, the COM terminal. Usually the COM terminal is placed in such a way in either to indicate positive or negative reading. So here they didn't mention anything about the negative or the positive reading, but notice that they are telling me to measure the voltage UBC. So always the second letter, the second point, is related to the COM terminal. So for example, if the voltmeter is measuring UAB, then the COM terminal must be connected to B. If the voltmeter is measuring UMN, then the COM terminal must be connected to N. If the voltmeter is measuring UBC, then the COM terminal must be connected to C. Okay, so in this case, the COM terminal is connected to the point C simply because the voltmeter is measuring UBC. So this is the COM terminal, and the other terminal will be at the point B. So as for part 2.1, this is done. Now in 2.2, they are telling me UPB is equal to 0, justify. So notice that across P and B we have an ammeter, and we know that the voltage across an ammeter is 0 since it is of negligible resistance. The voltage across an ammeter is 0 since it is of negligible So in this case, UPB is equal to 0. So notice that here, because they are asking me about voltage across a branch, so now we expect that they ask us about the law of addition of voltages. Indeed, in part 2.3, they are asking me to show that Upn is equal to UBC, and this can be done by the law of addition of voltages. So let me say for 2.3 as the title, apply law of addition of voltages So always on the left we write the voltage of the battery, which is given by Upn. And on the other side of this equation, we will move from P to N across different electric components, making sure that UBC must appear in the equation. So UPA plus, so notice that A is not a point, it represents the other terminal of the ammeter. So from P to B, from B to C, and C back to N. Notice that here in the equation UPN and UBC must appear. So we will keep UPN as a variable and UBC as a variable. Now the value of UPB is 0 plus UBC. Recall that UPN and UBC, both of them appears in this equation, so both must be kept as a variable. And now as for UCN is 0 because we have a connecting wire. Notice that we didn't justify that UPB is 0 because it has been done previously. Now between brackets UCN is equal to 0, and the reason is given by connecting wire. So in this case we have that UPN is equal to UBC. Now in 2.4 they are telling me the voltmeter displays a positive value, justify. So the voltmeter will either indicate positive or negative value, and this depends on the COM terminal. So moving from the positive pole to the voltmeter, so this is plus and this is minus. So notice that the COM terminal is connected to the negative pole. Here they are not asking me about the indication of the voltmeter, they are just asking me about the justification why the voltmeter reads a positive value. So let's say since the COM terminal is connected to the negative pole, then the voltmeter will indicate positive reading. Then this is it for part 2.4. Now in number 3 they are telling me we vary the voltage of the UPN, we vary the value of the voltage UPN. So recall that UPN is of adjustable value across the terminals of the generator. The adjacent curve, they mentioned this curve, then now we can use it, gives the variation of UBC as function of the current I in the circuit. 3.1. Now till this moment we don't know the nature of the electric component D. So this curve represents the voltage UBC versus I. So notice that UBC represents the applied voltage of D. So this characteristic current voltage curve is for the electric component D. They are telling me that D acts as a resistor, justify. So notice that since the characteristic current voltage curve of D is a straight line passing through the origin, then this electric component can be considered as a resistor. So since the shape of the characteristic current voltage curve is a straight line, passing through the origin, then D acts as a resistor. Now in 3.2, determine graphically the value of the resistance R of D. So because we have the graph, the value of R corresponding to the electric component D can be determined using the slope method, which consists of 4 steps. So the first step, step number 1, is to write the definition, which is given by the resistance of the resistor is equal to the slope of the characteristic current voltage curve. So this is step number 1. Now step number 2 is to choose any 2 points belonging to the curve. Then let me choose this point to be the point A and this point to be the point B. Independent of the choice of the points A and B, the value of R will be the same. So we always start by the current. So notice that the point A has a value of current given by 0.02 amperes and a value of 1 volts. And as for the point B, then 0.04 amperes and 2 volts. Now step number 3 is to convert these values to the SI, but they are already in the SI. So we move to step number 4, which is given by the resistance R is equal to the voltage of the point A minus the voltage of the point B divided by IA minus IB. So if we have started with A in the numerator, then we start with A at the denominator and we end by B respectively. So now the value of UA is given by 1, the value of UB is given by 2. Now the value of IA is given by 0.02 minus 0.04. Now this is a fraction, so in order to calculate this fraction we need to calculate separately the numerator and the denominator, then reduce the fraction, and or in this case we can plug this fraction on the calculator. Then the value of R is given by 50. Since previously everything is expressed in the SI, so the value of R will be in the SI, which is ohms. Then R is equal to 50 ohms. Now in 3.3 they are telling me D is replaced by 2 resistors in series of resistances R1 and R2. So let's say as a title, R1 and R2 are in series. So usually this statement they give it half a mark. So by D is replaced by 2 resistors in series, so D replaces these two resistors, then D is said to be the equivalent resistor, such that R1 is equal to 30 ohms and the value of R2 is unknown, which is set to be X. They are asking me about to calculate the value of X. So in order to calculate the value of X, we need to fit the value X in an equation, which is said to be a linear equation. And this can be done by referring to the fact that R1 and R2 are in series. And their equivalent resistance is given by the component D of value given by 50 ohms. So let's say that R is equal to R1 plus R2, knowing that we are interested in determining R2, which represents the value X. Now the value of R is given by 50, the value of R1 is given by 30, and the value of R2, which is denoted by X. So indeed, we have determined an equation in terms of X, which is said to be a linear equation, which allows us to calculate the value of X. So what's the type of this equation? Linear equation. How do you solve it? We put X on one side and all the other numbers on the other side. Then 50 minus 30, this is equal to 20. Then X is equal to 20. Notice that here X doesn't carry any unit because already the value, so R2 is equal to X multiplied by ohms. So usually R2, the value of R2 will have unit which is ohms. So notice that in this case R2 is split into X multiplied by ohms. So X is a number that doesn't include any unit, and for this reason they have gave R2 the symbol X, which refers to the same symbol in math, in order to indicate that this value will not have a unit. Because now, if X have unit like this ohms, then the value of R2, which is given by X ohms, it will be 20 ohms multiplied by ohms, which is equal to 20 ohms to the power 2, which is wrong. Okay, so now in this case, if X is equal to 20, so the value of R2, which is X ohms, is equal to 20 ohms. So this is the correct answer. Okay, so it happens sometimes, most of the cases in physics, all quantities must have unit, but it happens sometimes that quantities doesn't include unit, and this is one of them. Okay, now let's move to the next exercise, which is extra exercise number 8. Now they are telling me document 1, they mentioned document 1, now we can use it. Shows an electric circuit that consists of a DC voltage source such that Gpion is equal to 20 volts. Then the trick in solving such type of exercises is to label the applied voltage on the electric circuit itself. So this is 20 volts. For resistors given by R1, R2, R3 and R4 such that R1 is equal to 8 ohms, R2 is equal to 12 ohms and R3 is equal to 10 ohms. Let me write them down here. Notice that the value of R4 is not given, which means the aim of this exercise is to determine the value of R4. Now a lamp L considered to be an ohmic conductor of resistance RL, the moment they mention that the lamp can be considered as an ohmic conductor, then we can apply Ohm's law to L. So the lamp L has the following parameters. RL is unknown, and it has the following indications that are given by 6 volts 0.5 amperes. Notice that I didn't label these indications on the electric circuit itself because yet we don't know if the lamp L is functioning normally. And an oscilloscope connected across the terminals of R1. So these are the terminals of the oscilloscope. Notice that till this moment they didn't mention anything about document 2, so we are not allowed to use it. Hence, the circuit is said to be closed and it's being traversed by a main current I as shown in document 1. The aim of this exercise is to determine the unknown resistor R4. Number 1. The voltage across R1 is being visualized on the screen of the oscilloscope as shown in document 2. Now they mentioned document 2, then we can use it. What does the oscilloscope measures, UAB or UBA, justify? So the reading of the oscilloscope, or what does it measure, UAB or UBA, can be determined by referring to the connection of the oscilloscope. Knowing that the oscilloscope measures from the phase to the mass, this is the phase terminal and this is the mass, then the oscilloscope measures UAB because the phase is connected to A and the mass is connected to B. Since the phase terminal is connected to A and the mass terminal is connected to B, then the oscilloscope measures UAB. So this is important. Now in 1.2 they are telling me determine the voltage across R1 measured by the oscilloscope. So notice that the voltage measured by the oscilloscope can be determined by the formula U is equal to SV multiplied by Y. Here we have the value of SV and we have the value of Y because this is the luminous line which is displaced upward. Now the oscilloscope is measuring UAB. The value of SV is given by 2, and because the luminous line is displaced upward, so it's given by plus, and the number of divisions is given 1, 2. So this is equal to 4 because everything is expressed in the SI, so the value of UAB will be in the SI, which is volts. So UAB is equal to 4 volts. And I repeat, the trick in solving such type of exercises is to write the applied voltage on the electric circuit itself. So this is 4 volts. Now on 1.3, deduce the value of the main current I traversing the circuit. And by deduce, it means that we have to use the previous part. In the previous part, we have determined the applied voltage across R1. And already we know the value of R1, which is given by 8 ohms. In general, the value of I can be determined either using the law of addition of currents or Ohm's law. So in this case, because we have determined the voltage and we know the value of R1, so the value of I can be determined using Ohm's law. So notice that R1 is being traversed by the current I. Then apply Ohm's law. To R1, and this law is given by U is equal to R multiplied by I, knowing that we are interested in determining I. So constructing the triangle of this formula here, because we have multiplied and U will be at the top, R and I at the bottom, we are interested in determining I, which is given by U divided by R. The value of U is given by UAB, and the value of R is given by R1. So 4 divided by R1, which is 8, which is equal to 0.5. Since everything U and R are expressed in the SI, so the value of I will be in the SI, which is amperes. So I is equal to 0.5 amperes. And now let me label the value of the electric current on the electric circuit. So I is equal to 0.5 amperes. 0.5 amperes. Because I repeat, the trick in solving such type of exercises is to label the applied voltage and the traverse current on the electric circuit, and this is I, which is 0.5 amperes. Notice that in this case the electric circuit is being traversed by 3 currents, I, I4 and I3. I is the main current in the circuit, which is traversing the main branch. So this is the main branch, okay, in which these branches are sub-branches. Now in 1.4 they are telling me what does the indications carried by L represent. Let's start by 6 volts. It's the rated voltage of the lamp L, under which it functions normally. Now as for 0.5 amperes, it is the rated current of the lamp L, under which it functions normally. Now in 1.5 they are telling me justify that the lamp is functioning normally and deduce its applied voltage that is given by UEF. So notice that this part consists of 2 parts. This is the first part and this is the second part. Let's start by the first part, which is justifying the functioning of the lamp. So notice that in this case the value of the traverse current is 0.5 amperes, which is equal to the value of the rated current. Always, in order to describe the functioning of the lamp, we need to compare the applied voltage to the rated voltage, or we can compare the traverse current to the rated current. So here let me say, since the traverse current is equal to the value. So since the traverse current is equal to the rated current of the lamp L, because 0.5 amperes is equal to 0.5 amperes, then the lamp L is functioning normally. Okay, so now because the lamp L is functioning normally, then its applied voltage is given by 6 volt. They are asking me about the voltage UEF. So UEF is equal to 6 volts, and the reason is given by normal functioning. Now in 1.6 they are telling me to calculate the resistance RL of the lamp, and this can be done using Ohm's law. So apply to the lamp L, and this law is given by U is equal to R multiplied by I. Notice that we are interested in determining the value of R, so constructing the triangle of this formula. Here, because we have multiplied and U will be at the top, R and I at the bottom, we are interested in determining the value of R. So putting R hand over R, which is denoted by RL, this is equal to U divided by I. So notice that here, the value of the applied voltage is given by 6 and the value of the current is given by 0.5. Because the lamp is functioning normally and because we are calculating the resistance, no need for the lamp to function normally. We can determine its resistance using the indications that are given by 6 divided by 0.5. We can say that this is UEF, for example. So this is equal to 12 ohms. Now in number 2, determining the unknown resistance R4. In 2.1, they are telling me UPA is equal to UDE is equal to UFN is equal to 0. Notice that across P and A, D and E, F and N, we have a connecting wires. So the voltage across a connecting wire is 0. For this reason, UPA is equal to UDE is equal to UFN is equal to 0. Now in 2.2, they are asking me to determine the voltage UBC across the resistor R2. We need to determine this voltage. Now one can think about the law of addition of voltages, but in this case we cannot determine the voltage UBC simply because we have another unknown which is given by UCD. So always the law of addition of voltages yields to a linear equation, and which allows us to solve only for one unknown, but in this case we have two unknowns. Therefore we might think about Ohm's law, because we know the value of the electric current traversing R2 and we know its value, which is given by 12 ohms. Then apply Ohm's law to R2, which is given by U is equal to R multiplied by I. No need to construct a triangle for this formula because we are interested in determining the value of U, which is denoted by UBC across the resistor R2 traversed by the current I. The value of R2 is 12, the value of I is 0.5, so this is equal to 6 volts. Then UBC is equal to 6 volts. And the trick in solving such type of exercises is to label the applied voltage on the electric circuit itself. So this is 6 volts. Now in 2.3, they are telling me deduce the voltage UCD, and by deduce it means that we need the previous part. Notice that in 2.1 and 2.2 we have discussed voltages across different branches. Then UCD can be determined using the law of addition of voltages. Then apply law of addition of voltages. Then how do I apply this law? Always on the left we write the voltage of the battery, which is given by Gpion. And on the other side of this equation we'll move from P to N across different electric components, making sure that UCD must appear in this equation. Then from P to A to B, B to C, C to D, D to E, and E back to N. So we are interested in determining the voltage UBC. Now UPN is equal to 20, UPA is 0, UAB is 4. Sorry, making sure that UCD is kept as an unknown. So UPN is 20, UPA is 0, UAB is 4, UBC is 6, plus UCD kept as an unknown, plus, so UDE, this is 0. So here we have, sorry, UEF and F back to N. So UEF is 6 and this is 0. So this is equal to 20, which is equal to 16 plus UCD. So what's the type of this equation? This is a linear equation and one unknown. The unknown is UCD. So UCD is equal to 20 minus 16, which is equal to 4. Since everything previously is expressed in the SI, so the value of UCD will be in the SI, which is volts. So UCD is equal to 4 volts. And let me label this applied voltage here. Now 4 volts represent the applied voltage across R3 and R4, which is the same because they are in parallel. Now in part 2.4 they are telling me show that the electric current traversing R3 is given by R3 is equal to 0.4 amperes. Now we need to determine the value of I3. I3 can be determined using two different laws that are given by law of addition of currents and the law and Ohm's law. Okay, but notice that in this case we cannot apply the law of addition of currents because here we have two unknowns that are given by I3 and I4. So, and we know that the law of addition of currents will yield to a linear equation which allows us to solve for one unknown. So in this case we cannot use the law of addition of currents, we need to use the law, Ohm's law. Then apply Ohm's law. Here Ohm's law can be either applied to R3 or R4, but since we are interested in determining I3, the electric current traversing R3, then we need to apply it for R3, which is given by U is equal to R multiplied by I. Constructing the triangle of this formula here, because we have multiply, then U will be at the top, R and I at the bottom. We are interested in determining the value of I, which is denoted by I3, across the resistor R3 having an applied voltage UCD. So this is equal to 4 divided by the value of R3, which is equal to 10. So this is equal to 0.4 amperes. So I3 is equal to 0.4 amperes. Now in 2.5, they are telling me deduce I4, the value, the electric current flowing through R4, and by deduce it means that we need to use the previous part. In the previous part you have determined the value of I3, which is given by 0.4 amperes. So the value of I4 can be determined using the law of addition of currents. So apply law of addition of currents. Then how do I apply this law? Always on the left we write the value of the main current, which is given by I. So notice that because I at the point C will split into two currents that are given by I3 and I4. So it's the sum of different currents traversing different branches. Knowing that we are interested in determining I4, the value of I is given by 0.5, the value of I3 is given by 0.4 plus I4. So what's the type of this equation? This is a linear equation and one unknown. The unknown is I4. Then how do we solve it? We put I4 on one side and all the other numbers on the other side. So the value of I4 is given by 0.1 amperes. So I4 is equal to 0.1 amperes. And we need to label this electric current on the electric circuit. Now finally in 2.6 they are telling me show that the value of the unknown resistance is given by R4 is equal to 40 ohms, and this can be done by applying Ohm's law to R4. Then Ohm's law is given by U is equal to R multiplied by I, knowing that we are interested in determining the value of R. And here because we have multiply, then U will be at the top, R and I at the bottom. R, which is denoted by R4. So the voltage across the resistor R4 is given by UCD, traversed by the current I4. The value of UCD is given by 4 divided by the value of I4, which is given by 0.1. Plugging this fraction on the calculator, then the value of R4 is given by 40. Since U and I are expressed in the SI, so the value of R will be in the SI, which is ohms. So R4 is equal to 40 ohms. And indeed, the aim of this exercise has been okay, so we have determined the unknown resistance, which is R4. And as for the final exercise, extra exercise number 9, they are telling me the electric circuit of documentary consists of a DC voltage source such that Upn is equal to 12 volts. Two resistors R1 and R2 of resistance is given by R1 is equal to 36 ohms. And R2 is equal to 30 ohms. A lamp L carrying the following indications 3 volts and considered to be an ohmic conductor of resistance RL is equal to 20 ohms. So by ohmic conductor it means that we can apply the law, Ohm's law, to this lamp. And notice that in this case we didn't label the applied voltage on the electric circuit because the rated voltage, because yet we don't know if the lamp L is functioning normally, and a switch K. Now in number 1 they are telling me initially the switch K is open. What is the value of UPA across the open switch? We know that always an open switch in series with the battery have the same voltage of the battery. For this reason, UPA is equal to 12 volts. Now in 1.2 they are telling me, is there an electric current traversing the circuit justify? We know that an open switch doesn't allow electric current to pass through. So in this case, I is equal to 0. Now in number 2 they are telling me now the switch K is closed and a main electric current I traverses the circuit. They are telling me UCN is equal to 0, so here let me close the switch. So notice that across C and N we have a connecting wire. Let me say the voltage. So UCN is equal to 0. Then in 2.2 they are asking me about the voltage UPA, which is across the closed switch, which acts as a connecting wire. So in this case UPA is equal to 0. So whenever they ask me about voltage across different branches, now I expect that they ask me about the law of addition of voltages. Then indeed in 2.3 they are telling me deduce that UPN is equal to UAC, and this can be done using the law of addition of voltages. Then in 2.3 apply law of addition of voltages. Then how do I apply this law? Always on the left to write the voltage of the battery, which is given by UPN. And on the other side of this equation, we'll go from P to N across different electric components, making sure that UPN and UAC must appear in the equation. Already UPN appears. Now we will move from P to A, because A appears here. Notice that going from A, we can go from A to C in two different ways. We can directly go from A to C or across the point B. So directly to C it will be UAC. Across the point B it will be given by UAB plus UBC. But because we want UAC to appear in the equation, so we'll go directly from A to C without going across the point B, plus UCN. So keeping UAC and UPN as variables. So UPN is equal to UPA, which is 0 justified previously, plus UAC plus 0. So in this case UPN is equal to UAC. Now in 2.4 they are telling me to calculate the equivalent resistance R prime equivalent to R2 and L. So notice that L is a lamp, but because it can be considered as a resistor, which is ohmic conductor, which means that we can calculate its equivalent resistance. Now notice that R2 and L are in parallel. And the equivalent to resistance, which is denoted by R prime, is given by 1 over R prime, which is equal to 1 over R2 plus 1 over RL. The value of R2 is given by 30, the value of RL is given by 20. Plugging this fraction on the calculator, then its value is given by 1 over 12. 1 over 12 represents the value of 1 over R prime. So in this case R prime is equal to 12 ohms. And whenever we calculate an equivalent resistance, it's convenient to represent this equivalent resistance in the new electric circuit. So R prime replaces R2 and L, then the new electric circuit is given by so this is P, A, B, C, and across B and C we have R prime, and this is R1. And the value of R prime is given by 12 ohms. So now, for each question, we have two different electric circuits in order to refer to. Now in 2.5 they are telling me, show that the equivalent resistance corresponding for R1 and R prime is given by R equivalent is equal to 48 ohms. So notice that R1 and R prime are in series. So usually this statement they give it half a mark, and the equivalent resistance is denoted by R equivalent, which is equal to R1 plus R prime. The value of R1 is given by 36. The value of R prime is given by 12. So this is equal to 48 ohms because R1 and R prime are expressed in the SI. And because we have determined an equivalent resistance, let's represent it on the electric circuit, replacing R1 and R prime. So notice that in this case, the point B will disappear. We are left with the points A and C across the battery, which is Gpion. This is 12 volts, this is 12 volts. So now I repeat, to each question we are being asked, we have 3 different electric circuits to refer to. Now in 2.6, verify that the value of the main current I is given by I is equal to 0.25 amperes. So in order to determine the value of I, so here we don't have different branches in order to determine the value of I. So I usually can be determined using 2 different laws that are given by the law of addition of currents or Ohm's law. Here we don't have several branches in order to determine the value of I, although here we have 2 branches, but we don't know the value of the electric current traversing the lamp nor the resistor R2, so we cannot use the law of addition of currents. So we are left with Ohm's law, so apply Ohm's law. Now here we have several electric components to apply Ohm's law. We have R equivalent, R prime, R1, R2, and L. Notice that U is equal to Ri, which is Ohm's law, so I using Ohm's law is given by U divided by R. In order to determine I, we need to determine U and R. We have all the values of R, but notice that we only know one value of the voltage, which is given by UAC, which is across R equivalent. So we will apply Ohm's law to R equivalent, which is given by U is equal to R multiplied by I. Constructing the triangle, knowing that we are interested in determining the value of I. Putting our hand over I, then the value of I is given by U divided by R. U of UAC over R equivalent. Notice that in this case UAC is equal to UPN is equal to 12 volts because we have justified this in 2.3. And the value of R equivalent is given by 48. Plugging this fraction on the calculator, then the value of I is given by 0.25. U and R are expressed in the SI, so the value of I will be in the SI, which is amperes. So I is equal to 0.25 amperes. And because we have determined a value of the traverse current, we need to label this current on three electric circuits. So this is 0.25 amperes. This is 0.25 amperes. And here we have 0.25 amperes, which represents the main current and the main branch. And in this case, we don't know how this current will split at the point B. So what we know is that the sum of these two currents will be 0.25 amperes, but we don't know yet the splitting. Now in 2.7, we need to deduce the voltage across the lamp L is given by UBC is equal to 3 volts, and by deduce it means that we notice the previous part, and the previous part we have determined the value of I. U can be determined from I by applying Ohm's law. And in the previous part, so first of all we need to determine UBC. So we need to choose an electric circuit that contains the point B. So electric circuit number 3 is eliminated and we are left with this one and with the first one. So in this case we will use the second one because in deduce it's related to the second electric circuit, which is this, and we know the value of the electric current and the resistor R prime. So apply Ohm's law to R prime. U is equal to R multiplied by I. No need to construct a triangle because we are interested in determining UBC across R prime traversed by the current I. The value of R prime is given by 12. The value of I is given by 0.25. Plugging this on the calculator, then the value of UBC is given by 3 volts. So UBC is equal to 3 volts. And let me write here that this the applied voltage is 3 volt and this is 3 volts. Now finally in 2.8 they are telling me the lamp L functions normally, justify. So the functioning of the lamp can be described by comparing the rated to the applied. So notice that since the applied voltage which is given by 3 volts is equal to the rated voltage of the lamp L, and this is because 3 volts is equal to 3 volts, then the lamp L functions normally. So that's it for me in this video guys, see you soon in a new one.